Hey everybody, back to more Rust. Okay, so where I left off, I wrote a little to-do for myself: add, append, insert, remove functions, because we were fooling around with this sample code that was doing. All right, let me stop this. That was doing linked list manipulation, but it was kind of a really simple linked list because it was sticking stuff in inserting to the front of the list always only. And I thought it might be kind of interesting to try without being prompted to append, insert, and remove things. Oh, and by the way, there's a Patriots game. Go Patriots today. Let's see, hopefully they win. Anyway, so let's see. First thing I want to do is, I can't remember how far we got with linked list. So let me just enter a message here. Base functionality. Oh, I gotta commit this. And the reason I'm gonna do this is so that I can always go back, right? Because now as soon as I start making changes, it's going to notify me that I'm making changes, and then I can, if I really mess something up, I can just undo and go back. So that's usually a good practice here, to just block something down. Now, yeah, I don't know whether we're going to need to create a second branch or not. I don't remember what I did with linked list, whether I created it on GitHub yet or not. Anyway, so we'll just carry on and we'll see what happens. Actually, I guess, can I just check? No, I haven't, because there would be evidence down here of me doing the typing all that set of incantations into the console, but it's not there. So, all right. Anyway, well, let's move on. Okay, so what do we want to do here? We've got a list, and it's got this thing, and then it's got the list, or it's nil. And then we've got new, which creates a nil list. And we've got prepend, which takes the list and removes or adds a new element to it. So let's see. So if we wanted to, let's say, remove. Let's do the reverse of this. Remove. And this will be remove first element. It'd be self. And then we only need self. Right? We don't need to add something to the element. So single arrow. Going to return a list. And what are we going to do here? We want to take the list. We want to subtract the first element from the list. So it's so we want to return. All right. So I think we need to create a let new list equals. Self. So, I mean, in theory, the idea is that you would take the list, find the first element, and then return that first element's list as the right answer. Oh, actually, that's exactly what I want. So it would be self dot right, because it's what's this? This is it's this thing, box list. How do I refer to that? Oh, it's brackets. This is a tuple, right? So I can self dot one. Right? I think that'll do it. Right? So because this is self dot zero and this is self this whole thing here is self.1. Although I'm not sure I want to return the box. I want to return the thing inside the box. This ampersand box list. Maybe I want to return that. I don't know. Well, let's try this. This is the simple one. What's this? What are you complaining about? Quick fix. Remove first should have a snake case. Oh, okay. Yeah. Right. Naming convention. Okay, that's that. All right. So, oh, what's this? What's this? No field 1 on type list. Huh? But this list. Oh, cons. But what? No, but this thing is list, right? This thing is an enum list. So I don't know. Ampersand self. Star self. Oh, here. Ref tail box list tail. So I think maybe this is what I want to do. I want to take what? Where did box list ampersand box. No. Ref tail. Oh, okay. All right. No. Oh, if it's one of those, then I want to do tail.stringify. Okay, and this was an ampersand box list. Tail is an ampersand box list. Now this self is a list. But if I say ampersand self, then what's this? This is an ampersand list. Well, how did this thing get to be an ampersand box list? Star self. Ref tail. What? All right. Where did tail come from? Ref tail? Oh, I wonder if I need to do ref self. X equals ref self. Okay, what do we got here? What's this thing now? Oh, all right. Save this. All right. What's this? This says. Okay. About ampersand self. Oh no, that's double ampersand. Yeah. Star self. That's a list. Okay. And then return. Oops. Now what? What's this problem? What's the problem? Cannot move out of star self, which has shared reference. Because okay, so I'm trying to copy. So I don't want to copy. I want to reference x dot 1. Well, it says there's no 1. Oh, come on. All right, here. Well, let me just copy this because I think this is... Let me just copy this and put it here because I have a suspicion. Okay. What's this? What's this problem? What? Unexpected enum list found U32. Alright. What the heck? Oh, right. We were expecting to return a list, and we instead ended up with a U32. Okay, I get what the problem is. Oops. Control Z. Delete. Delete. How's that? Well, now what? Expected enum list found reference to ampersand box list. Expected list because of return type. Well, yeah. Yeah, oh dear. Don't I want to return a list? Or don't I want to maybe I don't want to return a list, but I do. I want to return, just like this thing returns a string, I want this to return a list. So if self is, it can be either this or it can be nil. So then if it's this, I want to return the tail. Borrow rather than move is not part of the pattern. It's not affected whether the pattern, only how it is matched. By default, match statements consume. This is like a little magic incantation here. So I found a reference to box list. So how do I unbox a list? So here's an example of how to box one up, but I don't know how to unbox. In this one, it was boxed, but it was okay because I was just looking for the length. But in this case, I actually want, okay, so I think what I'm going to need to do is I'm going to need to do a little search here. Rust language unbox variable. Okay, how to properly unbox a value. Okay. Let me make this a little bigger so I can read it. Okay. There was a special syntax for unboxing values and box patterns. Box for, and then match X box in. But since this syntax has been moved behind a new feature gate and attempt to reduce the special cases around box type, nowadays you'll see that. Okay. Still we're setting for the box pattern. You can avoid it or enable the syntax explicitly, but I would just avoid it. Right now is you can move values out of boxes using star box. Star X. Star X. Alright, let's try that. Star X. Alright. Let's try the star. So, star tail? Well, no, that didn't. Okay, so then tail is, what's this? Consider unboxing the value. I just did. Did you not pay attention to what I just did there? Mismatched types. Expected enum list found struct box list. Oh, I got rid of the... Oh, how about ampersand, star. How's that? Okay. Well, you give me the... Oh, hang on. Why are you complaining? Nil. No. Nil. I want to return... not 0. I want to return... nil. What's this? Cannot move out of star tail, which is behind a shared reference, which occurs because star tail has type list, which does not implement the copy trait. I don't want a copy. I want the original. Oh, but I guess two people can't own the original. Because the problem is, oh, do I want to make a copy? Because the problem here is that, all right, so only one something can own a piece of memory, as I understand it. And I guess what I'm doing here is I'm saying, hey, I would like to return part of this memory as a, ooh, it was a slice thing, right? There was that slice thing. I wonder if slice will work here. Slice. Alright, what's the problem here? Try calling slice as a method. Oh, I see. Self slice 1. No method named slice found on reference &list in the current scope. Okay, so I've got nothing. Perhaps you need to implement it. Yes, I do. Ring slices, click for. Okay, so I have to implement. Nothing for free here. Okay, so let's try that again. So this block of memory, I'm saying I would like to return this block of memory, but then I'll have two references to the same block of memory. Right, and this comment says, can't take ownership of the tail because self is borrowed. Instead, take a reference to the tail. That's what it did. Ref tail. Okay, and then I went star star, or maybe ampersand star. Oops, sorry. Oh, come on. No, that didn't work. What have I got here? So expected enum list found reference to ampersand box list. Okay, so how about star ampersand? Now what did I get? I got still ampersand box list. Okay, so tail is ampersand box list, and if I say star by itself, then this gives me it is a box list. So I want to unbox, which what if I don't do ref tail? What am I getting in? So this is box list, and then this is tail. What's this? What's the ... here? Oh, and we just moved the problem to a different spot. Okay, so that doesn't do it at all for me. That's just not going to work. Okay. All right, so I do not know how to do this. Okay, so this is returning a box square brackets list, and I want it to return a list, but I can't have it return exactly the list, because exactly the list is already, that memory is already owned by somebody else, and so I cannot take ownership of it. but the but I also don't want to make a copy of it because that doesn't make any sense to me. Like, why would I make a copy of it? So really what I want is I want it to return can I return? No, but I actually want, see, the thing is, I mean, I want to remove it. So I don't want to just return like, well, because that was one option, right? Is to return a new list with that first element missing. And then I would have just kept on working with that new list. But that one at the beginning of the list would, I guess, be lost memory. So what I actually want to do is I want to delete the first element from list. So if it's nil, I just want to return nil. But if it's this, what I want to do, I actually want to do is I want to I don't care what the first element is because I'm deleting it, but I want to grab the element at the second spot. Let's see if I put curly brackets in here. Let new equal or new list equals tail zero tail 1. Can I do that? Unknown as index. No, that's not working. That's not working. Tail dot 1. No, that's not working. Expected enum list found. Oh, right. Okay, so tail dot 1. Field 1 obstruct box is private. Private? When did that happen? All right. Clearly, I don't understand anywhere near enough about this language to be able to do anything here. Just kind of bumping into stuff. So, all right. You know what we're going to do? We're going to abandon this effort because there is no way. I don't know anywhere near enough. I kind of can visualize what the problem is, but how to make the syntax do what I want it to do, we're not there yet. Or I'm not there yet. All right, so that's unfortunate, but that's the way it goes sometimes. Sometimes you just have to abandon ship. All right, so let's see. Let's go back to here. And, where'd it go? Where'd it go? There it is. All right. All right, let's move on. Oh, but box. See also box. Let's try one last thing. Box, stack, and heap. Where have we jumped to? Oh, we've jumped to 19. All right. Well, we're not at 19. We're back at 3. So, okay. Actually, 3 enums. We were at enums, and then type aliases, right? And then test case linked list. We were here. Okay, so let's just move on because I don't want to jump ahead to 19 just to figure this out. All right, constants. Constants. Rust has 2 different types of constants. An unchangeable value, a possibly mutable able variable with static lifetime. Static lifetime is inferred and does not have to be specified. Accessing or modifying mutable static variable is unsafe. So static Rust, okay, constant threshold 10. So, okay, and then this is language, error, cannot modify the constant. Okay, whatever. Let's move on. Variable bindings. Okay, Rust provides type safety via static typing. Variable bindings can be type annotated when declared. However, in most cases, the compiler will be able to infer, which is what we've been seeing. Those white letters are inferring the context. Values like literals can be bound to variables using the let binding. Let this, that, the other thing. Let copied an integer. Okay. Print those things. Unused variable. Compiler warns. Noisy unused variable. Fix me the prefix with an underscore to suppress the warning. Please note the warnings may not be shown in a browser. Okay. Oh. These warnings can be silenced by prefixing the variable name with an underscore. Oh, so when I got rid of those underscores, I was going, hey, why does this thing have an underscore? Like, follow the convention. They were following the convention, I guess, in the sense that they wanted to silence the warning about unused variables. Well, okay, I wonder why. Unless you are in the middle of coding something and the warnings are annoying you, I don't see why you'd ever want to not get warned about unused variables, because you can just delete them. Anyway, whatever. That's fine. I'll forget that one too. I'm not sure I care about that. Mutability. Okay, what's this? Variable bindings are immutable, but this can be overridden with the mut modifier, the mut. Mutable binding 1, and then we can change it. We've already experienced this where we've had mutability. Scope and shadowing. Variable bindings have a scope. All variables have a scope. var in JavaScript is global. Let is within the enclosing set of curly brackets. Presumably we've got something similar to that. Are constrained to live in a block. Block is a collection of statements enclosed by braces. Yeah, so the nearest set of curly brackets defines the scope of your variable. So let means that from there to there it exists and then it no longer exists. And if you try to reference it, it's going to give you an error. Okay. And variable shadowing is allowed. Oh, I don't like this. Shadow binding, shadowed binding, use it, and then outside we're using this one. See, this is like asking for trouble. So, because I'm going to look at this, like, this is easy because we see it right here. But in a larger block, you could quite easily lose track of the fact that you've declared two variables with the same name and get to this point and go, I don't understand why this variable is not the value I set back here. So I don't like that at all. Okay. Declare first. It's possible to declare variable bindings first and initialize them later. Let initialize, yeah. Uninitialized variables. You don't want uninitialized variables. So initializing them to something, and I guess they don't get initialized to anything by default. So, well, I guess it can't because let another binding. I wonder though. All right, and I'm going to do this in the code. I have the linked list code because I don't feel like opening a project just for this. But my question is, what happens? All right, we're going to remove this because I am done with trying to figure this out from chapter 19. All right. All right. What I want to know is if I declare a variable, let x, and then I say print line x, and then I say x equals 1. Okay, so this is an I32. But if I said colon I32 explicitly, oh, then I get all sorts of warnings here. So I get warnings immediately. Used binding x is possibly uninitialized. Okay. And then this says value assigned to x is never read. Okay, cool. So if I don't give it a name, if I don't give it a type, then, well, I saved it and I got the warnings. Okay, so if whether I give it a type or not, I'm going to get a warning. So hey, going to say this is possibly uninitialized. This is never read. Okay, so then if I add that in, colon I32, sorry, colon I32, colon I32. So either way, this is going to, hey, it's going to say, hey, binding was left uninitialized. It's going to give me an error condition. Okay, so yeah, it's going to warn me about this uninitialized variables. And it's really not going to let me do much with it. Okay, so that's cool. So fine. Right, we're happy there. Freezing. Data is bound in the same name immutably. It also freezes. Frozen data can't be modified until the immutable binding goes out of scope. Let mutable integer that. Shadowing by mutable integer equals mutable. Oh no. Our mutable integer is frozen in this scope. I can't change it. But here I can change it. Seriously, I can assign itself to itself the same name, and it knows that this one refers to that guy and this one refers to a new variable. Oh, it's painful. Okay, fine. I mean, I guess it's kind of fun, but maybe there's a use for that. But that gives, I don't know, not so keen on that. Okay, types. Several type mechanisms, casting, literals, blah, blah, blah. Right, casting. So we did this, I think we did this as you, whatever. Yeah, and we had the problem, decimal, right? And this is going to be an error because there's no implicit conversion. We had to do that try because this thing has more, like U8 is an 8-bit value and this is a floating point value with many more than 8 bits. So you can't do this assignment. It won't fit it in. You can do an explicit conversion. Oh, look, as U8 and assign it to integer. Okay. And integer as char. Oh, okay, well that works. That might have been an easier way of doing what I did back then, because I said, you know, try, will it fit or not? And this thing, I'm not sure what's going on here, because if this, obviously this decimal number, well, no, not really. That decimal number is, okay. Error. There are limitations in conversion rules. A float cannot be directly converted into a char. No, that's what I had. I had float. I had float. No. I had U size. It was U size. When casting any value to an unsigned type T, max plus 1 is added or subtracted until the value fits into the new type. $1,000 minus 256 minus 232. Under the hood, the first 8 least significant bits are kept, while the rest towards the most significant bits get truncated. Okay, yeah, sure. Okay, so it's truncating. That's interesting. All right, so what do we got here? We have this idea that we can mush things into something smaller. We can, that if it's too large, we will lose some bandwidth before it works. Now, I wonder, all right, let's go and try something here. So, let x equals, all right, so 65 point, 32. Okay, and then we'll say let x equal x u8 or equals decimal as u8. Okay, and then print line x. Okay, so let's run this. There, just run this. Okay, 65. So 65 point whatever, we lose the decimal places and we get 65. All right, let me try this as, 256 is the most you can fit into an unsigned 8. So it goes from 0 to 255. So if I enter 256, I'm expecting that x is going to be 0 based on what they said. Let's save that. Let's run that. 255. That's not what you said you were going to do. What you said you were going to do is subtract 256 until it fit. But that doesn't look like what you did there. All right, let's try something bigger. Let's try 512. Because that's 2 times 256. So again, I would expect a 0. Yeah, still getting 255. Let's try 513. Because maybe there's the subtraction. Nope, still 255. All right, let's go back and read this documentation again, because it sure sounded like, because it said, hey, we're going to take 1,000 and we're going to subtract and subtract and subtract until we get there, and we're going to, the first 8 least significant bits are kept, while the rest are truncated. So here's the thing, is that 513 is 1 0 and a bunch of zeros and then 1 at the end. And the 1 0 at the beginning should be truncated because, again, numbers go from 0 to 255. So 255 should have given me 255 back because that's all the lower binary bits are on. But 256 is the 9th bit is 1 and all the other bits are 0. So that should have given me 0 according to this, but it's not. So why isn't it? Now, is it because this is an integer and I'm actually mucking with a floating point number? Let's try that. Let's see if that's the case here. So, okay, let's let y equals decimal as u16, and then we'll go y as u8. Going to give me that, and then I'm going to do two things here. Y is that, x is that, and then y comma x. All right, and let's run. Okay, so 513 and 1. Now the 1 finally makes sense. 513 truncated to a U8. We got the low order bits. There's only one low order bit on, all the other ones are off, so cool. So it looks like, all right, let's try, I'm not going to speculate quite yet. So a U16, the numbers range from 0 to 65,535. So if I say 65,537, 37, then that's 2 too many. So in theory, if it truncates it to a U16, I should lose the high order bit and be left with 2. And then U8 should also be 2. So let's save that. But yeah, 65,535 and 255, right? Because 65,535, that's all the bits are on. All 16 bits are on. And then, of course, the low order bits are also on, so which gives me 255. So when this overflows, then I guess the floating point number, gads. Okay. So, but if I made this a U32, as U32, because now a U32 is up to 2.4 billion. 0 to 2.4 and change billion. I don't remember the exact number. Sorry. So now if I run that one, then that one, there, it gives me all those bits, and then the correct bits are on, and then of course in a U8 just the low order bit is on, so we get the 1. So I was thinking about that. When I said 2, I was contemplating, is it really 2? No, it's not. It's 1. Okay, so all right, so what seems to be happening is this floating point number is just, when we do this to a number that overflows, we just get -1. Because -1 is all the bits are on. That's no matter how many bits there are, a -1 is all bits on. Yeah, so that when the higher order bit is on, that means minus. So -1 is the all ones, which is the largest number, but really it's the smallest negative number. And then as you start adding zeros, you are getting larger and larger negative numbers as long as the higher order bit is set to 1. All right. So if we overflow the integer version number of bits, then we just get -1, it would appear. And if we don't, then we get the actual number that we want. All right. So that's interesting. There we go. Okay. What else have we got here? Okay, so that was the U16, 1000, U8. We're going to get that. Minus 1 I8 as U8. Again, minus 1 is all ones. So we say minus 1 I8. What we're saying is 8 ones. 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. And then U8, that converts it. So now we're switching from minus 1 to, well, it's all ones. So all ones as an unsigned number, if you now take that high order bit and say, well, that's part of the number, it's not the sign that says it's negative, then it's 255, because 8 bits is 255. 8 ones is 255. So, I mean, they can explain it this way, but basically that's what's going on in the bit pattern. For positive numbers is the same as modulus. Okay, cool. Yeah, mod 1. So it's just extracting that. When casting to a sign type, okay. Oh, that's weird. Okay. This one here. Right, well, actually, that makes sense. Because if 128 is 1 and then 7 zeros, if that's a signed number, then that's going to be minus 128. That's the largest negative number. 1 and all zeros, 1 in the higher order bit and all zeros is interpreted as the largest negative number, which in this case is minus 128. So the range actually of these things is not exactly symmetrical, because there's that darn zero. So it goes from minus 128 to plus 127 with the 0 in the middle. So anyway, but if it's 1 and all's remaining are zeros, then if you interpret that as a unsigned number, that's the 2 to the 7th, 2 to the 8th bit, 2 to the 8th, whatever, 2 to the 7th bit is turned on. And yeah, because 0, 1, 2, 3, 4, 5, 6, 7. So 2 to the 7th is on, and 2 to the 7th is 128. So yeah, that's the way to interpret that. Okay, and then what's this? The as keyword performs a saturating cast when casting from float to int. If the float point exceeds the upper bound, return value be equal to the bound crossed. Oh, so here's explains our weirdness with the floating point that we experienced. Okay, and this behavior incurs a small runtime cost and can be avoided with unsafe methods. However, the results might overflow and return unsound values. Use these methods wisely. To int unchecked, to int unchecked, to int unchecked. Okay, well, so we had a better way of doing that when we were doing that conversion to from usigned to integer. So we can kind of do that. All right, cool. Literals. What do we got here? Numeric literals can be type annotated by adding the type as a suffix, and we've experienced that already. Yeah. Oh, and size of, we actually experienced size of as well, and oh yeah. So it's like where, right? This is the kind of namespace-y stuff. So it's like we've got a namespace where we can find size of val. So standard memory, and then size of val is the function we want to use. Yeah, okay, cool. But we've run into a lot of this already. Inference. Type inference engine is pretty smart. Okay, it does more than look at the type. It also looks at how the variable is used afterwards to infer its type. Yeah, we experienced that when I was trying to get that to work, right? We change something and it would go, oh, that's what this type is. And then you'd change something else and go, oh, no, you meant this type. And I could never get it to fit right. Well, now we're fitting right. Okay, because of the annotation, the compiler knows that LM has type U8. Okay. Create an empty vector, a growable array. Oh, okay, vec. At this point, the compiler doesn't know the exact type of vec. It just knows that it's a vector of something, underscore. Okay, that's how we explain something. We push element. Aha, now the compiler knows that it's a U8. Okay, so it's interpreting that. So what happens then? All right, let's try this. I'm going to copy this. What happens if I then so I got the vector, new thing, a vector of U8, we push element, we do that, but what if I push vec.push 65.2 F32. Then what? Oh, it doesn't like that. Can change the type of numeric literal from F32 to U8. But okay. So looks like once you've assigned a particular type of data to this vector, you can't do anything else. Because I think it'll be happy now because 65 is within the limits of a U8. But if I say 365, oops, wrong place, 365, it's going to complain because you have to be 0 to 255, and we're out of that range. Okay, so the compiler is going to help us out here, and the compiler's not going to let us put random stuff in this vector. Once we've established what is going into the vector, we can't change it later without going back and changing everything, which is cool. I like that. That's good. This is like the C# has these anonymous types that kind of work in the same way. You can create an anonymous type. As soon as you assign something to that anonymous type, then it knows what type it is and it won't let you change that type. All right, so cool. All right, I like that. All right, so that's inference. Okay, aliasing. Type statement can be used to give a new name to an existing type. Cool, I guess. Types are must have upper camel case names or the compiler will raise a warning. Oh. The exception to this rule are the primitive types, usize F32. Type, nanosecond, U64. U64, inch, U64. Okay, interesting. Note that type aliases don't provide any extra type safety because aliases are not new types. Okay. Well, all right, so this is good in a sense. I mean, it's convenient because then you don't have to worry about what is the unit that we're working with, right? So if you're going to do an area calculation, you know, you can define a number to be a floating point number, and you can just refer to it as area or whatever, right? And that's convenient because it means that you can give more specific names to things. I mean, the variable should also, but if you've got lots of variables that are manipulating some type of thing and you want to make sure the nanosecond ones work with the nanosecond ones, then you don't want nanoseconds to add to inches. I mean, this isn't going to enforce that, but at least I guess when you hover over it, you'll go, oh, this particular variable is a nanosecond type, and this is a actually, let me just make sure that that actually is true. So if I hover over these, will it tell me what will it tell me? What will it tell me? Okay. Oh, and these have to be capitalized, it said. Okay. Oh, that's a little interesting. All right, so now if I say let nanosecond equals 7, and then print 1 ns. Right, so when I hover over ns, oh darn, no. Well, that kind of blows, because it didn't tell me nanosecond. It told me U64, which kind of defeats the whole purpose. You know, because if I'm using this variable somewhere later on and I say, hey, what's this thing? Should I be adding it to some other thing that's also of type nanosecond? And I'm going to have to go back and see the declaration, because this isn't going to tell me. That's too bad. Because they would have been nice if that had popped up and said ns:nanosecond. Then I would know. It's like, all right, this is a nanosecond and that's a whatever it is, and let's not combine those two. All right, then that's the 365. So let me make that 165 so I don't have an error. And then ns, yeah, still U64. Just thought maybe it was not, but no. Okay, so that's kind of a problem. I don't know. I mean, and it's this guy, right? It's the editor, because presumably the editor could be smart enough to figure out that it should say nanosecond here. If you're the guy who created this plugin, you know, maybe you can fix that for me. All right, let's carry on here. Where do we go here? All right, aliasing, and that's it. All right, what do we got? Oh, it's almost 8 o'clock. So that's types. Not a whole lot of coding happening there. Conversion from and into. Oh yeah, we kind of played around with this. We already kind of fought with this from and into thing. Define how to create itself from another type. Okay, so string : from my string converts it into a string, right? Because that was an ampersand stir, and this is a string, right? And so we can do this from thing, and it will. So from 30, number from 30, capital N number. Okay. Into reciprocal of from. And into calls from. Okay. Int into number. Okay. So if int is 5, into is number. Okay, whatever. So yeah, we can convert things. Try from and try into. This is the other thing we bumped into, right? He said, oh, we should figure this out. Our generic traits converting between types, unlike our for fallible conversions such as returning result S, right? So if it were to fail, then we've got the ability to deal with it. Now, interesting here. Remember, mine was like, oh, this is okay or error. Oh, I see. They're trying to figure out whether something's even or odd. And we're either going to return an even number or we're going to return an error. Okay. Cool. But we had a different structure here where we kind of just tacked the OK onto the end, dot OK. But it looks like you can do that or you can call it separately. Okay, that's nice. The chaining thing was fun. And, okay, to from strings. Again, this is we bumped into this already. Converting to a string, convert any type to a string, to string. You should also implement the format to display to automatically provides to string. So if we have a display, we can call to string. Well, that's interesting. That's kind of nice. Parsing a string, one of the more common types of converting a string is into a number. You're right, parsing. There you go. How do we do that? 10.parse int32 unwrap. Ooh. Unwrap. Unwrap. What's unwrap? Unwrap. I wonder, could my linked list have worked if I'd said unwrapped? All right, let's go have one more try. One more try. Oh, I deleted that, did I? I did. All right. Let's... right, and I copied this. And I'm going to return, if it's nil, I'm going to return nil. If it's that, I'm going to return tail. Oh, hang on a second. How was that? That was not, it was, it was dot unwrap. Yeah, that's not going to work. Well, you know, never know. Oh, what's this? Oh, I didn't copy far enough. I need missing a curly bracket. Now it fails. No method named unwrap found for references box list. Okay, so that was something special for integers. Whatever this data type is here. So this 10 parse returns an I32, but then you call unwrap. So, okay, parse is doing something that requires me to call unwrap on whatever it returns. So I'm curious. Let me take this. What does parse return? Where are you? There you are. Okay. Okay, so that is happy. But if I break this into two pieces, let q equals the parse, let x equals q dot unwrap. All right, result unknown. Oh, it's a result. That's what. So we're unwrapping a result. Got it. Okay, because parse could fail. So this thing returns. All right. So if I say parse I32, then this. Oh, this is now a Boolean. Q. What? Oh, that. What? the heck happened there? Parse, use colon, colon, I32. Oh, okay, there we go. So it's going to return a I32 or a parse int error. And Q is a result, and that was the colon thing I missed. So that returns a result, and then this, I unwrap it, and unwrap returns me back the I32 part, I guess. Returns the OK, contained OK value, consuming the self value. Because this function may panic, its use is generally discouraged. Oh. Instead, prefer using pattern matching and handle the error case explicitly. Right. So this was kind of cheating because they don't like you to do this. So this pattern matching we had up here, or where we kind of did match. Okay, and then I'm going to say equals 0, and then I'm going to say match. How does that syntax go? Match that variable q, curly brackets. Are you going to be helpful? You're not going to be helpful. If it returns an if it returns an I32, but I want to give that a name. Okay, so if it returns an I32, so I fat arrow x equals I comma error let's see, colon 32 colon 32 E colon parse int error I'm going to say print line error. What's that? Is it going to be happy with that? No, everything's wrong. Jeez Louise. All right. A local variable with similar name Q exists. Well, yeah. What are you complaining about? Use of undeclared crate or module I. Oh. What do I... So, I don't know. Am I supposed to do something like that? I don't understand. Oh, yeah, maybe I am supposed to do that. And then we don't know what I is. X equals Q dot. Found enum result integer. Oh, well, that's an enum. 0? No. I don't know. So I want to reference the not error part. So how did he do that here? He referred to the variable. So this populated it. So I don't really. So this I32. just, I don't know. All right, I don't know what I'm doing here. All right, so now I'm totally messed up here. What's going on? I think what I want to do with this match is I want to specify the two possible conditions, right? But in this case, I want to specify either the parse int error, or I want to specify that I want the int32 part of the result. And Q is the result, but this is a okay, so this says opt, what's this? Opt none usize. Match opt some or none. Oh, can I do it that way? Some int, oops, x equals int. Oh, no, that, didn't like that. Some t, some value of type t, mismatch. Expected enum I32 parse error found enum option. Oh, okay, so that's, no. So, I32. Expected a tuple struct. Oh, okay. I32 parse int. No, that doesn't make any sense either. Expected enum. Oh, unless I need to say result. I don't know. What am I expected to say here? All right, let's try, see if I can get some help here. Rust. Parse. Match. String parsing, Rust cookbook. Match that. Okay, error. Is that the parse though? No, it's from str, and from str does something different. I don't know what it. So, because this is, you got to say return that or return that. Oh, but interesting. It's like return that brackets. So it, I mean, in our case, it appears that what it's returning is an I32 or a parse int error. So if I said, but so if I say I32 bracket int, didn't I try this already? Yeah, and it didn't work. But parse int error bracket. Nope, that doesn't work either. I don't. What is the name of this thing? Because when I hover over it, it says it's an I32, but it should have a name. Like it should be like OK and error, but we're not getting. I don't know what the names of these things are, and it's an enum, and an enum is. But why does an enum have angle brackets? I don't know. All right. So I tried to do search for parse and match, but how about if I search for parse int error? All right, I'm going to search for Rust lang parse int error parse and match. How to construct a parse int error handling. Handling error variants. Parse int error. Okay. This is not helping. All right. Okay, that's not what I wanted, because that's somebody doing the work and he knows he's returning OK and error. I'm trying to figure out what it's actually returning so I can match on that. Yeah, well, let's see. Sometimes these guys have something useful. No, that doesn't help me. It's a different question. Yeah, I don't know. So nobody does this. So the reason there's an unwrap is because nobody actually does. All right, fine, whatever. That's why the unwrap is here, because there doesn't seem to be anybody who does it the other way, even though it says, hey, you should use the right, don't, all right, it was unwrap, it was in the code. It said don't do that. So if I say, right, dot unwrap, or call, because this function may panic, its use is generally discouraged. Instead, prefer pattern matching and handle the error case explicitly. Oh, wait a minute. Yeah, that's, it returns the OK value. So this returns OK. So, but then there's other unwraps, which unwrap error. All right. Or default. unwrapper default. Returns okay if it contains value, otherwise returns error. Okay, so then I can say, oh, then why is this? Match Q. Okay. Error. Well, hang on, but this, okay, so unwrapper default, God, makes no sense. Okay. Goodyear from input parse, unwrapper default. Yeah, but show me the error case. Oh, hang on. Bad year, this will return 0. Oh, okay. Or default. Okay, we don't want default then. So unwrap or else. Yeah, there we go. Unwrap or else. Count. Count. Returns the OK or computes it from a closure. Length. What? Count. Where's count come from? Count. Oh, there it is. Sorry. In the example, count is the name of the function. So unwrap or else count. We pass in count, which is the length of a string. We want to convert. Okay. All right. That's not what we want either. I'm not going to get one that's going to unwrap error. What's this one return? Panics if the value is an OK, with a custom panic message provided by the OK's value. Oh, okay. So no, that's not what we want either. We don't want it to give us grief. Unwrap or, what's this do? Argument pass. Okay. All right, we're not getting there. We're this. No matter what we do here, we don't see this unwrap thing is not going to return an error. Well. This function may panic. It's generally discouraged. Okay, so we don't. Instead, prefer to use pattern matching and handle the error conditioning. So I was assuming that what I do with the match is pattern matching, but maybe not. But you would think that if I searched for, which I did, Rust Lang match and parse, you would think somebody would have the thing I care about. We've got argument parsing, we've got regular expressions, the awesomeness of pattern matching. All right, forget it. I guess we're just going to have to live with unwrap and suffer the consequences of it failing. Or, although, I mean, unwrap or default kind of makes sense, because we could do that and say, hey, you know, if it fails, just set it to 0. Or whatever number we want. Or -1 or whatever it is. So I think that's probably our best compromise at this point, because clearly don't understand enough to be able to actually do what I wanted to do. That seems to be a fairly common theme. All right, so what are we working on next? So we're going to go on to expressions next time. And a series of statements, right? Okay, blah, blah, blah. Well, that'll be quick. Flow of control. If, else, while, for, blah, blah. Okay, this will be quick. Yeah, so we'll do this flow of control stuff and functions. We need to get to the interesting stuff, so we'll get to there. All right, that's it for now. I'll see you guys later.